Hi, I welcome you all to another class of calculus. Today, I will be showing you everything you need to know in a function of a function. So, some might call it chain rule because it's just like when we are connecting different functions together. So, we chain different functions. So, some call it chain rule, or function of a function, or function in a function. For instance, so you combine logarithm and the quadratic function together. So you see, we have the quadratic function in a logarithm function, or you have exponential and trigonometry. So we have two different functions, but one will be in another one. So in that kind of a cases, we have what they call function of a function. And how can we treat this? And mind you, in any question in calculus, particularly differentiation, the most widely and important part of the techniques used in differentiation is function of a function. So it is the most widely used techniques used in solving question in differentiation. Even if you are working with product rule, the chain rule, and the quotient rule, and others like that, so you are going to be seeing the questions of function of a function merged together with the product rule or the quotient rule and other types of the rules. Okay, let's get started. Suppose we are given a function of y which is equals to z. So suppose y equals to z. So, and this z, it means it is the function of a y. And we still have another function. So let me just say I still define this z on a function of x. So if this one is a function of x, or let me just say I call this one the function, let's say f of z, and we still have z which is a function of x. So the general principles that connect the y and z together is, let's say y also will be the function of x, because y depend on z, and we also define z which depend on x. Definitely y can also depend on x. So it's just like if you have an assumption of, let's say here is x equals to y equals to z, for instance. So x can be equals to y here, and as well as y can be equals to z. So if these two are equal, definitely this and this are also equivalent. So that is what defines this particular function. So we are having a chain of a function. So function in another function. That's what we mean by the word chain rule. And how can we find the derivative of this particular chain rule? So it's very simple. So just apply this formula. So the formula for the chain rule function equals to, since I define it on z, x, and y, so we are going to have it as the y divided by the z. You firstly differentiate with respect to z here, then you also differentiate with respect to x, but this comes with multiplication. Then here you are going to have the z divided by the x. You see the left hand side there, the left hand side equals to the right hand side. So as far as this one is multiplication, so by cancelling these two, we still have what? The y divided by the x. So you can apply this formula for any question given in a differentiation. So as far as we are having two different functions combined together, you can apply this formula. But if it is three, let's say we have three different functions chained together, so how can we do that? So it's also very simple. So we can still apply the same thing. So as far as, let's say we have this one to be y equals to x, z equals to this. So we still define another function on another function. So suppose I use u. So I will still define u based on this x. Then we can get the formula for the three functions in a chain rule. So we can do that. Okay, let's see the beauty of this in a question. Okay, suppose we are given a question like this, required to find the chain rule, I mean the y, the x. So to do that, let's say here is example 1. Suppose we are given y equals to, let's say this is bracket, we have 5x squared plus 3x minus 1, everything raised to power of 3. Okay, you see, we have 5x squared, which is a quadratic function in this particular root. So the question is clear. So this is a technical example of chain rule. Though if you are very familiar with troubles, you can just expand all these things, then you lead yourself in troubles. But the best way to approach this is by applying the chain rule. So you let this one in a bracket to another function. Then as far as we let this, so what we let, the value we use to be equivalent to this will now become the function of another function, which is y. Remember, y is dependent, x here is independent. So we're now going to choose another dependent, so which will be depend on x. Alright, suppose I sample z as it was used in the examples above. Z equals to this. Here is 5x squared plus 3x minus 1. So as far as I let all this one to be z, definitely, so we are going to have y equals to z raised to power of this 3. Then the next thing to do is to find the derivative. So you differentiate this one with respect to x, differentiate this one with respect to y. So even if you like, you can still have this one as z of x, since it is defined on x equals to, here is x, 5x squared plus 3x minus 1, or you divide this one on y of z equals to z raised to power of 3. So let's take the derivative of this one. The derivative of this one, which is z prime of x equals to, so it still remains the z divided by the x equals to, let's differentiate this. Here is 10x plus 3, and by differentiating this as well, okay, we're going to have y prime of z equals to, here is 3z squared. Right? Now let's find derivatives of y and x. So to find the y and x, so we are going to have it as y prime of x. So don't misplace this. Here is z, here is x. So our final product should be the derivative of y not z. Okay, here we are going to have this as y prime of z dot z prime of z. So which one is also the z divided by the x. We are going to have it as the y divided by the x. Here is the z divided by the x. So then what is the y prime of z? That is 3z squared dot. Then what is this? We are going to have it as 10x plus 3. But remember that the z square, we have let it here to be 5x squared. So don't forget this 3 and create bracket plus 3x minus 1 all square dot here is 10x plus 3. So you can create bracket for this and create bracket. So here is the derivative of this particular function. Clear? Okay, if this is clear, let's see another example. So I'm going to be very fast now. So I just use this one since it's the first example. That's why I'm very slow. So let's see how to do this in a very fast way. So I'm still applying the same process, but I'm going to be fast. Okay, example 2. Suppose we have y equals to sine square of x. Definitely this is a function in another function. So we have sine square of x. So the first thing that should come to your mind is, so you will write this thing as y equals to sine x all raised to power of 2. Yeah. So this thing is different from sine of x squared. It's different. So they have sine square x, so it's still the same thing as sine of everything raised to power of 2. We are dealing with trigonometry. So the square will come before x, not on top of x. Alright, so we let this one to be, okay, I'm changing the value here. I'm using u equals to sine x, then y equals to u squared. So differentiating this, we are going to have the u divided by the x equals to the derivative of sine x, that is cos x, right? And the derivative of this u here equals to 2u. Then to obtain the y divided by the x equals to the y divided by the u dot the u divided by the x. So substituting this formula, what is the y du? Here is 2u dot. So the u dx, that is cos x. But u here is the u here is sine of x. Then we're going to have 2 sine x dot cos x. So if you like, you can take out the dot and you will still get the same thing. Cleared? So if this is clear, let's see another example. Another example here is I'm going to show you the function of the logarithm and the trigonometry. But before that, let's see the exponential first. Let's see the exponential. Okay, let's say we have number 4 and number 3 question. Suppose y equals to 4 exponential of, okay, let me just add this one as x plus 1. Alright, given this particular function, so you see that we have exponential and the linear function. Because the highest power of this x is 1, so we have the linear function and exponential function combined together, function in another function. So the first thing that should come to your mind is, let this one to be something. Okay, I'm using z equals to x plus, okay, don't let me use z. So just for you to know that you can use any alphabet as far as your differentiation is accurately. Okay, I'm using m equals to x plus 1. And the y here becomes 4 exponential of m. Alright, the m divided by the x equals to 1, right? The y divided by the m equals to 4 exponential of m. This still remains the same. Alright, so to obtain the y divided by the x equals to the y divided by the m dot the m divided by the x. Alright, so let's insert the value. What is the y, the m? We have it fit to be 4 exponential m dot, and the m dx is 1. Yeah, but so here, which is m, is still the same thing as x plus 1. Yeah, so we are going to have 4 exponential of x plus 1. So we still get the same answer because the highest power of this one is 1. So if the power change, so a changes must still happen to this. So So it's just like, let's say you have y equals to exponential of x, you know, the y divided by the x equals to exponential of x. So I'm letting this x to be x plus 1. Cleared? Alright, if this is cleared, so let's see another example. Another example of function of a function, so which you need to know. You need to know all these examples. They are very, very important. Okay, suppose you have exponential and trigonometry. Okay, let's call this one example 4. If f of x equals to exponential sine x. Okay, exponential and trigonometric function. So to do that is very simple. So you apply the same format as, let's say, z equals to sine of x, and we are going to have f of x equals to exponential of z. So here, let me be uniform. Okay, I mean to be consistent. So I'm still going to apply z of x here. Alright, let's see the z prime of x equals to cos x, and the f prime of x equals to exponential of z, right? And to obtain the f prime of z, f prime of z, don't be mistaken, f prime of z, because we are differentiating with respect to x, not z. So if I use z here, which means this become constant, right? Alright, so to find the f prime of x, so we use f prime of z dot z prime of x. So okay, here the f prime of z equals to exponential z dot, and the z prime of x is cos of x. And here we have, by doing this, you can take cos at the back, cos x, then exponential, what is it? That is sine x. Obtain the answer. Cleared? Okay, let's see another example. So another example for this function of a function, which you need to know, is when I have something like a root in an trigonometric function. Suppose y equals to sine root of x. Definitely is also a function of a function. So to do that, we let the entire of this root to be something. I'm using u to be root of x, and the y equals to sine of u. So to do this, you know that this one can still be x raised to power 1 over 2, right? And the u divided by the x equals 1 divided by 2 x raised to power of minus 1 over 2. And the y divided by the u equals to the cos of u. By making this together, we obtain the dy dx equal to the y divided by the u dot the u divided by the x. So which is also equals to, what is dy du? We have it as cos u dot y du dx is 1 divided by 2 x raised to the power of minus 1 over 2. But the u equals to root of x, right? Then we can have this as 1 over 2. So we can take this thing back, x raised to the power minus 1 over 2. And we have cos of u is root x. That is the final answer you can consider. But if you wish, so you can write this thing in form of this. And to do that, I'm going to write it at the top here. Note that if you have x raised to the power of minus 1 over 2, so it's still the same thing as 1 divided by x raised to the power 1 over 2. That is negative power law of indices. By transforming this, we have everything to be 1 divided by 2, then root of, okay, let me just follow the step by step. So if this one equals to this, then we have 1 over 2 dot 1 divided by x raised to the power 1 over 2, then cos root x. But root here, if you have x raised to the power of 1 over 2, it can still be root of x. So by changing this, we are going to have 1 divided by 2 root x, then cos root x. I believe we are getting the concept. If that should be the case, so let's see another question. So the question I'm going to show you now is going to be 3 different functions. But before then, I need a package for you. And the package is the shortcut to the function of a function. So there is a shortcut to it. So by letting that, so it can consume a lot of your time. As far as, let's say you are preparing for the exam, the computer-based exam, which is on calculus. So by letting this and by letting that can consume a lot of your time, since it is time, we have a time limit for that, unlike the written exam. So to do that, just follow this important step. So I'm going to use just only one example, then you can apply it for everything. And the example here is, suppose we have let's say this is shortcut. The shortcut. So the example, let's say you have y equals to cos raised to the power 4x. So the first thing you are going to do is just rewrite this thing as cos of x raised to the power of 4. Okay, let's start, guys. So the first thing is this power, you take it back. So you're applying the derivative now. That is y prime. Take this 4 back. Then differentiate this. You know, if you differentiate this, you're going to have minus cos x, right? So we write this again. We have this as minus sine x. Okay, we write this. We have cos of x. Okay, subtract 1 from this. That is 3. You see, it's very simple. You firstly take the power down, you differentiate this, you rewrite this one, then you subtract 1 from the above. Okay, this becomes minus 4 sine x, and then this becomes cos raised to the power of x. In just 3 steps, I obtain the y, the x for this thing. If this is clear, okay, let's see this tool as well. Suppose you are given y equals to x squared plus 1 raised to the power of 2. Still apply the same thing. So to obtain the y prime, you take these 2 back, differentiate this, we are going to have 2x. We write this thing, that is x squared plus 1. Then subtract 1 from this, that is 1. Here we have 2 multiplied by this, that is 4x bracket x squared plus 1. And you get the answer in just 3 steps. Function of a function is very simple to know as far as the proper steps is taken. Okay, the last example I'm going to do here is the function of a function of 3 different functions as well. Okay, let's see how to do this. Suppose we are given y equals to the function of x throughout. If y equals to a logarithm, which is the length, and the sine x squared. You see, we have three different functions here. Here is the logarithmic function, the trigonometric function, and the quadratic function. This is a typical example of function of a function and differentiation. So to do this, we take it one after the other. So just take it easy on yourself, so that for you not to stuck along the journey. So let's take it one after the other. So the first thing is, let this entire sine x squared, so the one that ended this, so you let it to be another variable. So I'm using z equals to sine x squared. Now this is different from sine square x. Alright, then we have the y equals, okay, let me use this side. So we're going to have y equals to ln of z, right? But this is another function in this. So to do this, it's very simple, right? So we still let this one to be another thing, but you can apply the shortcut I just show you right now. You can apply the shortcut actually. Alright, let this one as well to be equal to u, which is z x squared, right? Then since this one equals to u, z also become u sine of u. You see, I've defined this thing based on three different functions: 1, 2, and 3. Okay, let's start clearing it one after the other. So here, I'm starting from here. The y divided by the z equals to 1 divided by z. So the standard y, this which is the u divided by the x, equal to 2x. So okay, I call this one 1. Let me call this one 2. Okay, what of this? The z divided by the u. Here becomes cos u. Okay, we have three different things now, but our own aim is to obtain the y dx. To do that, apply this formula. The y divided by the x, remember your aim is to get the y dx. Just multiply everything. You are going to have the y divided by the x, the z, dot the u divided by the x, dot the z divided by the u. The formula is very simple. You know, if this and this cancel, this and this cancel, so we still have only what? The y dx, which is equivalent to this. Clear? If this is clear, let's start imparting what we got for each derivative. The y dz equals to 1 divided by z, right? Dot the u dx equals to 2x, while the z du is cos of u. Alright, since this one is under already, so we have 2x cos of, but u which we let is x squared divided by, but what is z? Z equals to sine x raised to power of 2, which is the required solution. Clear? But you might play it smart that here we have cos of x raised to power 2, sine of x raised to power 2. If you leave an answer like this, you are absolutely correct. But you can try to play it smart like a mathematician do it. You know, if you have cos of x divided by sine x, so this is automatically cot x, right? So which means that your answer here, if you wish, it can still be the y, the x equal to 2x cot x raised to power 2. You are still absolutely correct. So this will be the end of today's class. But as my usual act, if you always watch my YouTube class, I do give assignment at the end of each class. So today I'm going to repeat the same thing by giving the assignment, and the assignment goes thus. Please try to do this just for you to be assured of yourself that you really understand this concept, and drop the answer in the comment sections. I will make sure that I attend to every comment, and don't forget to like, subscribe, and share this to your friend. Even your enemy can still benefit from this. I will see you there. Alright, before you end this, so let's see the example as an assignment to you. The first example I'm going to give here is the 3 different functions combined together. Okay, so the first one here is, let's say you have y equals to exponential of sine x squared. While the second one here is, suppose you have y equals to sine. Okay, don't let me use sine. I think I've been using sine. I'm going to change the format to, let's say here is the root of cos. I love sine. The root of cos x. Alright guys, I'm stopping here for today. So see you in the next class. See you in the next class. Bye bye.